Welcome, everyone. This is Bobby Harris from the Utility Broadband Alliance, and it's my pleasure to welcome you here today to our webinar sponsored by Anterix. We're going to have some great members of UBBA sharing some knowledge with you today. And as you're getting logged in, on your webinar tool, if you have questions for the audience, you'll be able to type those in the question box. And then at the end, after the presentations, we'll get to as many of your questions as possible. And of course, we'll follow up with you all if we didn't get to your question offline. We'll do that. So again, I'm Bobby Harris, but I want to make sure and turn it over quickly to our panel so that you can hear what you came to hear. I'm going to start with Mark Paulin, the Vice President of Technology and Engineering from Anterix. And Mark, I'm going to let you just jump in and lead off. You've got a great slate of speakers here, and I'll be back later on when we do some Q&A.
All right, thanks, Bobby. Hi, again, I'm Mark Pullen, Vice President of Technology and Engineering at Anterix. We've got a great panel and presenters today. Let me introduce them very quickly. We've got Yaniv Levy, AVP of Marketing and Business Development from Sequans, John Yaldwin, CTO and founder of 4RF, Al King, Sales Engineer from RAD, and Mitesh Parikh, Product Leader at GE Vernova. We've got a great topic today talking about increasing flexibility and performance with private LTE communications. And I think as we move through this, and one of the points that I think you'll see as we go towards the end is just the collaboration of all the companies here, collaborating to really end up at a specific solution that'll be very helpful, we think, to the private LTE space and the utility market. I'll start off with just a quick overview of Anterix, my company, and then each one on the panel will give a quick overview of what their company does in relation to this utility broadband space. Let's see, get the slide to move here. Give it a second here. Doesn't look like it's advancing. All right, hang on. There we go. Hi, as Anterix, we are a nationwide holder of 900 megahertz broadband spectrum, and we make that spectrum available to electric utilities across the country for purposes of deploying private LTE networks to support communications in the smart grid. This 900 megahertz spectrum is licensed by the FCC, dedicated licensed. So any user of it is the only user of that spectrum. So this leads to a very great private LTE solution in terms of control of the private LTE network, being able to design for the reliability and the resilience needed for critical communications, and the security that you need too. This spectrum is part of 3GPP global standard of spectrum. So what that means is that you get a robust ecosystem of products that can be used in this spectrum because the spectrum is used in the rest of the world for similar or other purposes. And that also, having a standard spectrum like this also provides an evolution path going forward because the global standards take care of that for you as long as you're participating in them. We currently have got a map here. We currently show them in the dark orange, the set of states that where our first 6 utility customers operate. We've also got in a lighter orange other states where we've got utility customers that are piloting private LTE in the Anterix 900 megahertz spectrum. And then down in the southeast, we also see other private LTE use in different spectrum. So that's my summary of Anterix. I'll hand it off to Yaniv to talk a little bit about Sequans.
Yaniv, you might be muted.
Okay, repeat myself. Thanks. So Sequans is the next link in the supply chain. We are a fabless semiconductor company for 20 years. And in the past few years, we were also elevated to design and sell our own cellular modules. So we are doing both chipset and modules, and we are doing it for the full range of IoT products. It starts with the very low rate, low power LTE and narrowband IoT, and goes all the way up to 5G and broadband. As we are specializing in this IoT space, we have advanced capabilities for metering, including low power and integrated SIM. And the focus of today will be obviously the Cat-4 chipset that we have, which we developed together with Anterix and the team, a dedicated module for this market based on Cat-4.
All right, thanks, Yaniv. Now we'll move on to Jeff, talk a little bit about 4RF.
Good afternoon, everyone. My name is John Yaldwin. I'm the CTO and founder of 4RF. We offer a number of different solutions to work with the exciting Anterix spectrum. We have radios that are based on modules from 2 different vendors, and our focus is very much on maximizing return on investment with spectrum. As I'm sure you've seen from the various announcements, it's not cheap to acquire private spectrums, so utilities want to make the best from that investment. And to get the best from that, you need solutions that can handle multiple frequency bands, and this is where the Sequans CBRS module comes in. It supports CBRS and, of course, the Anterix Band 8. But also there are other sort of multi things that we need to think about. We have utilities, once they've invested, that want to run multiple applications on the same LTE network, and that requires features like VRF, virtual router instances, to support those multiple applications. So apart from the multi-band aspect with the CBRS and Band 8, or in some cases Band 8 and other selected spectrum, apart from the multiple applications, there are also multiple connectivity options. We see customers that want to use LTE, but they also want to blend that with private radio, using one or other as a backup for their primary network requirement. And this multiple connectivity extends further to fiber and networks like GPON. And it might seem strange to mention fiber in a discussion about LTE, but the reality is that most utilities want to have a couple of different connectivity means, and that means blending a solution based on existing network and new network technology. The last thing I want to touch on briefly with the Anterix spectrum, and I hear this sometimes from people say, well, look, you know, it's wide open space and CBRS, we can run 5G. Well, that is true. The Anterix spectrum is only 3 megs wide, and that is true as well. But what does that actually mean in terms of practical throughput? Well, the 3 meg Anterix spectrum with 2x2 MIMO does support 22 megabits in trials, and we've been impressed what is possible with the Anterix spectrum, and we think it's a really valuable addition to a utility spectrum toolbox that allows deployment in both private cellular and private radio networks. Thank you, Mark.
Thanks, John. Let's move on to Mitesh.
Right, well, thank you, Mark. Good afternoon, everyone. Thank you for joining today's webinar, and special thanks to UBBA for hosting this session with the industry partners. I'm really thrilled to be here with all of you. As I begin discussing our company, it's really hard to contain my excitement given the upcoming journey we are about to embark on at GE. We are undergoing a significant transformation with the creation of 2 industry-focused companies, as you may be aware of, GE Aerospace and GE Vernova. Despite this change, we remain deeply rooted to our 135-year-old legacy as GE. The name GE Vernova is really a nod to our past and present future. Ver, the first three characters, really symbolizes the Earth's rich ecosystem, and Nova signifies the new beginning, and we are really excited for this new beginning for our energy-focused company. We are committed to electrifying the world while decarbonizing it, and all of our business, or each of our business lines, have a significant role to play in achieving this mission. As you can see on the top left slide corner of the slide, the GE Vernova will have three segments. One is the conventional power, wind, and lastly the electrification systems. And we are part of the electrification systems. The big product portfolio that I'm leading is critical infrastructure communications, and we are really a portfolio of solutions, not just focusing on the wireless, but we also have optical networking, as well as the teleprotection signaling portfolio. Those who are interested will be at DTEC, of course, so we'll love to kind of see you at DTEC in person and talk about our portfolio and go through the details. I will spare you from talking about the optical networking and other things today. We'll focus on wireless, as that's the topic of the day. Speaking of wireless, we have our GE MDS Orbit family of radios. These are the LTE devices that we have for various different applications that meet customers' needs. We have three different form factors, ECR, MCR, and OCR. And the key thing that I really want to hone in, like John said about 4RF, and we kind of play in the same domain, right? Our goal is to provide solutions to our customer and flexibility and resiliency and reliability they need to operate their networks, especially the private LTE networks that require that resiliency. We already support Anterix, CBRS, and 450 megahertz, and so on and so forth, the other solutions, but we are really excited with this multi-band, multi-mode solution that we are looking at from Sequans, which will bring significant advantages to our customers. So looking forward to engaging dialogue today with you all. Thank you. Thank you, Mark.
Thanks, Mitesh. Next up is Al.
Great. Good afternoon. I'd like to thank all the folks at UBBA and Anterix for providing us the opportunity to meet and speak with you today. If you're not familiar with RAD, RAD is a telecommunication company that's been around for 40 some years. We're a global company. And like our fellow companies here, we provide solutions in both fiber, wireless, TDM. We have a vast array of products that fit into both the carrier space and the utility space. We've taken a couple of our products, our SecFlow products, and have actually focused those products utilizing the Sequans module to meet these requirements. We have a couple different versions of them, and the SecFlow is really kind of the Swiss Army knife of substation router, utility-based equipment. It has a vast amount of capability with the Sequans module in it, of course, supporting the Anterix spectrum, CBRS, and the public carriers as well. And the box also supports fiber, Ethernet, serial, and it can function. It has multiple functions within the utility network. It can actually function as a hardened substation router. It can be a Anterix-based broadband router. It supports, of course, CBRS, and we have multiple versions of it. And the goal of this is to meet the requirements of the utility space. It has the pedigree of a longstanding support and background of a communications company with the innovation of a very agile development and R&D company. So we're really looking forward to getting this out into utility networks and putting it to the test.
All right, thanks, Al. All right. As I mentioned a few minutes ago, one of the things I want to talk about today was the collaboration between everybody that's here on this webinar. And to start with, just at Anterix, we have an active ecosystem program which has over 100 companies as members, and it's really designed to get providers of solutions and products that can help the utilities in every aspect of their journey to deploying and operating private LTE system. So it ranges from from service providers to cellular infrastructure to devices, all aspects, field services. And today that's an eye chart, so don't want to dig into it. But today we're kind of focusing on the part of the ecosystem program that's really devices, chipsets, and modules. That's really the topic of today. And so when I'm going to move on to the next slide, why devices, chipsets, and modules? This chart just it just quickly shows the relationship, right? LTE devices, basically any device is starts with the chipsets that are used inside of it. Chipsets often are part of a module, an RF module that makes its way into an end device. Sometimes the chipsets themselves are in the end device, and you end up, when you have a good selection of chipsets and modules, you have a lot of end devices available to be used. This particular chart has a list of the relevant chipset vendors that we deal with in the Anterix 900 megahertz spectrum in the US. Today we're focusing on Sequans, the second on the list, and we're going to talk about the collaboration between Sequans and 4RF RAD and GE on CBRS and 900 megahertz. So that's what we're gonna focus in on. And so really, I'll kick off the discussion here, and then we'll start to go back and forth a little bit with some comments. But in general, it was about 2 years ago. We were getting feedback from some of our utility customers that were either interested in or deploying CBRS along with 900 megahertz. That the products that were out there that supported both CBRS and 900 megahertz were expensive, higher performance targets than what they needed. The reason being was that there's not a single module or single modem solution that supported both our spectrum and CBRS. So the products that supported both CBRS and 900 at the time were multi-module devices, which are more costly, tend to be, again, maybe more performance than is needed. So you're going to pay the price for that. Perhaps that slows down performance when switching from one band to another, things like that. And so there was a desire for a single module solution that supported both 900 megahertz and CBRS to improve on cost and performance. And so as we saw that, we started talking to members of the ecosystem, and Sequans had something that they could do to offer a module, a cost competitive, performance competitive module that supports both 900 megahertz and CBRS. And in collaboration with 4RF RAD and GE, we're able to move forward with creating that module. And now we're at the point where that module is soon to be available in products. So with that, I'll hand it off to Yaniv, and he can talk a little bit more about the module itself. And Yaniv, perhaps focus on some of the challenges and some of the market gaps and things like that you were addressing as you proceeded with the design.
Okay, so before we teamed up together, Sequans was very active in the CBRS market for several years. This is thanks to our background in the early days, where we focused on 3.5 gigahertz. We realized that most of the market, already when we were in CBRS market, most of the modules and most of the solutions were of higher categories and more expensive solutions. We already were focusing on more cost optimized solutions. And Cat-4 was also ideal for the Anterix spectrum. The main challenge in the market was that you couldn't have single module that could address both. In many cases, you either had high-end LTE devices or low-cost Chinese CBRS devices, and you had different devices with that could address the 900 megahertz. We have decided to team up together in order to create single module that covers both Anterix and CBRS and provides fallback to all the US MNO bands. So you can have the most cost optimized device that can address broadband, utility broadband. From a Western source, so all of our design of the chipset and the modules and the manufacturing of the modules is done in the West, and as such is also address the national security concern and geopolitical constraint of this sensitive utility market and energy sector. As John already said, Cat-4 is the sweet spot for addressing both the speed needs without going too high on cost. And the failover feature that we have both private LTE, CBRS, and Anterix with ability to fall back to any of the major MNO bands provide the resilience that is often needed in kind of backup. We are also anticipating that full migration to full PLTE network on each utility will take several years, and over time you will be able to migrate more and more devices into your own PLTE. So we can support this gradual migration.
All right, thanks, Andy.
Yeah.
Okay. Along those same lines, Al, could you say a few words about from RAD's perspective, on market need and challenges that you saw that this type of module could address?
Yeah, absolutely. One of the things that we've identified in not just in the North America market, but in the global market, is the need for multiple communication paths to provide the resiliency and redundancy that utilities are looking for. So when you start looking at primary, secondary, and tertiary communication paths and the applications that can be supported on those, whether you're in a substation, you're in a recloser, you need to have the reliability to be able to monitor that device, and you also have to go into many different types of environments. You have to go into a substation that has an awful lot of requirements. You have to be able to meet the security requirements, and depending upon where you're deploying, you may have different communication paths that are available to you. You may only have a private LTE path, or you may only have fiber in that area. So when you start looking for redundancy for critical applications, this is where we really see of course the benefit of the Anterix spectrum is that not all utilities anywhere are going to have fiber. They're not all going to have a private broadband network. And where Anterix comes in is that it can be that primary network connection. It can be a backup connection. So we see devices that support multiple modes of communication, and one of them being private LTE, both the Anterix CBRS and having the ability to even fail over to the commercial networks as an incredibly important part of deployment strategies for utilities.
All right, thanks, Al. John, I was wondering if you could comment on some of the primary drivers and use cases that require both CBRS and 900 from your perspective.
Okay, well, look, I will comment on that, and I also would like to comment on a couple of the points that Janov has also mentioned. One of them is the issue of foreign source equipment and sensitivity in the US and many other countries to products sourced from China. The second issue that I wanted to touch on is one of supply chain diversity. You know, we're still suffering from supply chain constraints, and the ability to source product from more than one supplier to suit the Anterix need is really important. So we talked a bit earlier about multiple applications and multiple connectivity for the manufacturers, also the issue of multiple suppliers. So that is really key point. The other issue is, you know, where product is built, and we manufacture in the US, and that works really well for us. We ship from the US to more than 150 countries around the world. So we're very proud of our US presence, despite my obvious New Zealand accent. To your point about applications, this is a very interesting area because there are a wide range of applications within the utility networks. It's not possible to generalize. You have applications that are highly cost sensitive in devices that are deployed extremely widely. Devices, for example, capacitor bank controllers or reclosers with extremely large number of devices within networks. In other applications such as substations, there are far fewer substations within the distribution network, but those sites often have a multiplicity of devices that require communication. So at substations, the data backhaul requirement is a lot higher. And also at substations, there is much more criticality in the network. A failed substation will affect large numbers of customers, whereas, you know, recloser failing on a line is only going to affect a small number of customers. So at the substation, we have very demanding requirements such as IEEE 1613 for electromagnetic compatibility and transient protection. And also at substations, there's often the availability of fiber because of the value of the asset. There will often be fiber connectivity, but LTE is absolutely required to provide a diverse connection. There are many incidents that can affect fiber. You know, backhoe fades where a digger digs up a piece of the road and you lose connectivity. So LTE is a vital failover for that kind of application. So it's difficult to generalize when you talk about the electricity network. You can say a few things about it that apply pretty well universally, and that's transient protection, electromagnetic protection, rugged, robust, wide temperature range operation. You know, it's pretty critical when you consider the deployments in roadside cabinets where there's no AC, and you imagine Arizona, it's exposed to some of the temperatures that we see today. You know, you need something that's going to work quite happily at 70 degrees C, you know, 50 Fahrenheit. Those temperatures are quite realistic in the network. So it's a demanding environment. There are different cost sensitivities in different parts of the network. You asked about the different band purposes. Well, you know, you need to understand the physics here, that with CBRS, you have a range of, you know, a few thousand feet, depending on where the antenna is located, maybe a mile or so, 3.5 gigahertz, fairly high frequency band, but of course delivers enormous capacity. So that's a very strong positive for CBRS. But of course, it doesn't have the legs of the low frequency spectrum. Down at 900 megahertz, the distances are much greater. Power levels are far less restrictive. The FCC controls the amount of power that can be used at CBRS. Alternatively, at 900 megs, there's far less concern about transmit power. So with gain antennas, we can do really long distances. So yeah, the key thing about having CBRS and Anterix 900 megs in the one module is that diversity of backhaul applications, where CBRS may be perhaps the primary backhaul, Anterix secondary, or you may actually have it the other way around. You may have a primary network on Anterix because you're going for the largest amount of coverage for the smallest number of base stations, but you're using CBRS in a few places where it makes sense. You can work with the lower range and save the spectrum at 900 for the longer haul application. So if you look at an area, for example, let's say California, there are many deployments where the short range CBRS makes sense inside, metro and city areas, but the Anterix band 900 megs is required to cover the rest of the state in the urban and more rural areas along highways and those sorts of things. So yeah, it's not one size fits all, that's for sure.
Thanks, John. Mitesh, can you make any additional comments on the area of use cases and drivers on between 900 CBRS?
Sure, no, we'll do. And one thing that I want to reflect on is the primary challenges that we kind of talked about earlier, that Al talked about. One of the things that we do see is also, the challenge that we'll address is the cost effectiveness and future proofing, right? Having the ability to support multiple bands in a single module will not only reduce the overall cost of the deploying the asset, but also maintaining the network. It also future-proofs, so that if you are working on if you're deploying a 900 megahertz spectrum in one of the region and you need to expand it to other, you don't have to keep you can leverage your existing infrastructure basically, and so there's a value that it brings. So having a multi-mode or multi-band solution will definitely help our customers. Regarding the applications, there are so many different applications that we can talk about, right? Especially in the smart grid communication, where you could have a distributed automation, for example, or fault detection. We talked about managing or monitoring the network assets. Some of these use cases doesn't require too much significant bandwidth. It may require a wider coverage area, and that's where the 900 megahertz, the Anterix band really plays a key role. But then when we are looking at more of a need of a real-time monitoring, there's a growing need of monitoring the devices real-time, do some predictive maintenance, analytics, and all of that requires significant amount of data to go over the network, and that's where the CBRS can play a huge role with the higher capacity that it can bring. So both of these technologies and our spectrum will bring the value to the customers and enable the use cases that they may not have been thinking about. And one of the other thing, we are collaborating together, right? And we are building this ecosystem to support this kind of a module, our technology. And as we have more and more the industry partners come along together, we will start enabling more and more use cases, right? They mean that we not be thinking of just not in utilities, but also in industrial or transportation and other sectors as well. So kind of a collaboration will by itself kind of enable new use cases that we haven't been really looking into.
All right, thanks, Mitesh. Al, one of the things you mentioned a few minutes ago was the multi-band aspect of CBRS 900 megahertz commercial spectrum for commercial MNOs, and John had mentioned it too. I was wondering if you could expand a little bit on how you see, movement between those and using all of them. Is there any advantage to a more seamless movement between those? Touch on some of those.
Yeah, great question, Mark. And kind of the way that I see it is that nothing is going to happen overnight. There's a lot of utilities now that are, of course, deploying Anterix spectrum. But there's a lot that aren't. They're looking at build outs. So one of the beauties of the Anterix module that was developed here with Sequans is that there's a migration path. Is that if a utility today is just evaluating. They haven't bought or deployed Anterix spectrum, or they may have some reservations about using CBRS in their area, is that they can start with the carriers. They can deploy on AT&T and Verizon and get that feel for devices operating in LTE spectrum. But then there's the migration path as they build out and as they build, because within the Anterix spectrum, they're going to be building out their networks, so they're going to be relying on systems integrators and engineering firms to build out the Anterix network. So there's this very smooth migration path from public carrier, CBRS carriers, CBRS capability to Anterix spectrum. And then when the Anterix spectrum is built out, of course, from experience, we know that there's going to be learning curves. There may or may not, hopefully not, be glitches or holes in coverage areas. So you'll be able, with one module, to make a smooth transition to Anterix spectrum, or from from Anterix spectrum back to fiber, from fiber back to LTE broadband. So the ability to have multiple communication modes and the ability to support all of those in one device is in my experience with the electric utilities, that is incredibly desirable.
All right, thanks, Al. John, since you originally kind of brought that up, any additional comments in that area?
Yeah, a couple of extra points I'd like to expand on. The issue of rollout is really a hot button topic for utilities, because there are a number of issues to get one's head around. There's obviously first off, the workforce requirement needed to roll out a large number of remote devices, but there's also the issues of rolling out base stations. So having modules that can operate on public carriers and then migrate over to the utilities private network is a key part of decoupling the rollout of the remote units, so that the rollout can go on. And in fact, I'd like to introduce, Mark, if I may, one of your company's products, and that's the Catalyx, which is a multi-SIM, single SIM that supports multiple carriers. So on that one SIM card, you can have both the utilities private network and a selected number of public carriers. And this means that you can deploy the remote sites even in areas where there is yet no utility private network. And through the magic of the Catalyx products, the remote devices will then migrate where the coverage becomes available from the public carrier over to the private carrier. And that's something that we've seen a lot of interest in. I should say, by the way, that we have various Band-Aid solutions deployed with a lot of the utilities that you've mentioned in your opening remarks, Mark. And this is the kind of feedback that we're getting, that there are constraints in the ability of the utilities workforce to do rollouts. There are constraints in how quickly the infrastructure can be built out. And indeed, there's another area which is quite important, certainly for RF believes it's important, and that's the ability to manage the bulk configuration, what we call provisioning of the remote devices. If you think about the issues in programming one cellular router, where you have to open up a laptop, plug it into the router and set various parameters, and then you multiply that by 10,000 or 100,000, it becomes almost unmanageable. And so you need to look to vendors that have the bulk provisioning and configuration tools that will allow that kind of assistance to bulk rollouts. It's a vital part. It's not perhaps so much important on the RF side with the LTE modules that we're talking about today, but it is critically important in those utilities' ability to provision, stand up, and make ready their private LTE networks.
Mm-hmm. Mark, you're muted.
All right, thanks, John. No, we're pretty far along. How about now? Is that better?
Good.
Is that better? Sorry about that. All right. You know, we're pretty far in now. I think we've had some great discussion amongst the panelists. I think it's a good time to open up the questions. See if any of the listeners have any questions.
We do, Mark. As a matter of fact, we had a couple of questions come in. I'm going to probably ask John to first answer this first one, and then of course others can weigh in also, but I think probably you're going to be the best to answer this one. So the statement in question is 900 megahertz is an FDD band, where CBRS is a TDD band, time duplexing. What are the advantages of each?
That's a very good question, and it's one of the advantages of the Anterix spectrum is that people often compare, you know, the 3 megahertz of the Anterix band versus the wider bandwidths that are available in CBRS. But of course, you have to take a deeper dive into that to understand the capacity support that either band provides. So with Anterix, you have the advantage of the fact that it's actually 3 plus 3. You have 3 megahertz up and 3 megahertz down. So the downlink from the base stations is not interrupted or shared with the remote devices. This means that the full capacity of the uplink and the full capacity of the downlink is available 24/7. When you look at the CBRS band, it's a different story. It's a time division duplex TDD, which means that you have to make an assignment between the percentage of the capacity, the percentage of the megahertz bandwidth that is going to be used for uplink versus downlink. And you might set the ratio as perhaps 10:1. That would be common in a common carrier arrangement where the assumption is that there'll be roughly 10 times the bandwidth being used from the base station to the remote and only 10% of the bandwidth used from the remote to the master. But of course, in the utility network, it's a complete opposite. You know, we have very little information going usually from the core network, and most of the information is being gathered from the remote devices. And so you spin that around typically in a CBRS deployment for utility networks, and we might have maybe 20% of the time allocated for the master to remotes and 80% for the remotes to master. So it's an insightful question because it highlights the fact that you know, the Anterix spectrum does have this advantage of having separate up and downlink bands, and that allows the up and downlink to occur simultaneously. The base station can be addressing large numbers of remotes while those individual remotes are contending for the uplink band. So yeah, it makes quite a difference. There is one other subtle difference, which I didn't touch on before when I mentioned range, and that is obviously the lower attenuation at 900 megahertz means that you can run more complex modulation. Now, normally we don't worry too much about that because it's the magic of the chipset looks after that for us. But even at Cat-4, we want to run with the most complex modulation to deliver the maximum bandwidth. We can only do that if the radio path between the remote device and the base station has low attenuation, and that's what you get at 900 megahertz. Now, when we look at CBRS, while CBRS will work in excess of 1 mile range, no question it can be made to do that, the attenuation is such that the modulation complexity has to drop down, which delivers less capacity. So it's an interesting reflection that when you look at real life CBRS compared to real life Anterix, you'll find that the capacities being delivered are broadly similar for the longer distance paths. So thanks for that question, caller, much appreciated.
Excellent, John, thank you. Any other comments to add to that?
I think so. I'll say something. I think John covered it pretty well, actually. You know, the key thing that I see in the Anterix band, which is you know, FDD, you know, because of the uplink and downlink communication, you will have advantage of improved interference mitigation, right? So that's a significant benefit advantage that you will get out of it, which gives predictability and also stable performance. Versus the TDD, I would say, you know, the key advantage there would be really the lower latency and the much faster response time. So that's why real-time applications is really suited for. So again, both has its advantages and disadvantages, but and depending on your application and the use case, I think user will be able to, or customers will select what would be their preference. A certain application may be more suited for TDD versus the FDD networks.
Thank you, Mitesh. If I can go ahead, we had another question from the audience, and Yaniv, I think obviously this is for you. Is the Sequans module offered in the M.2 format?
Yes, so as you can see on the slide on the right, you see the images of the module. So it comes in two form factors. One of them is the LCC form factor for soldering on the board, and the other one is the M.2. So you can have a choice. They are almost the same size. The M.2 is slightly bigger. So whenever you have more space optimized designs, you might select the LCC. Otherwise, you will select the M.2 for better flexibility.
Oh, excellent. I like having a visual with that one also. Thank you. And then, Mark, we had one other question come in just now, and I'll just read it straight out, and anyone can answer it. As Band 8 has overlap with Band 5, which is used by the carriers in the US, what is the exactly frequency range that can be used by utilities? That's the first part of the question. And then how to avoid interference between them?
Oh, I'll start with that one. So Band 8, as the question noted, Band 8 as specified internationally is actually a pretty wide band. It's 35 megahertz uplink and 35 megahertz downlink. We're talking about frequency division duplexing. But what we use in 900 megahertz is only 3 megahertz of that, and it's a specific 3 megahertz from 897.5 to 900.5 megahertz. So that's a very specific, it's a very specific. That's the 3 megahertz. That's the only 3 megahertz that we provide. That is a fair distance away from Band 5, which is a band that typically Verizon and AT&T use in the United States. That is several megahertz away from from Band 5. Is a good distance there to help guarantee operability on both sides, their operability and ours. So however, though, you always, when deploying, right, that's something you always have to be careful in your deployment and look out for scenarios that could create issues and require analysis. But deploying anything in the cellular world, you always have to be cautious of who your neighbors are and where their sites are and things like that. But coexistence is pretty straightforward because they're not that close to each other. There's a good separation from a megahertz perspective. Would anyone else like to comment on that?
Yeah. If I could jump in, Mark set out the frequency limits of one of the two bands for Anterix, but I think just to be really clear to the caller with the question, there is no overlap between the spectrum that Anterix is offering to utilities and Band 5. While they may exist in the same part of the RF spectrum, the actual band itself is not overlapped. And Anterix, part of the deal when you buy Anterix spectrum is that you have title to that spectrum and you can expect to use it free and clear. There'll be no one else there. It's a little bit like buying a house. You want to buy a property that's not cross-leased. You want to buy a property where you can go ahead and build whatever it is that you want to build, and you don't want to have to worry about someone else being in the same place. So there is no overlap with the Anterix Band 8 spectrum. That's one of the key advantages of it.
Excellent.
Thanks, John.
John. We did another question come in. Likely, Yvonne, that we will ask Sequans to lead with this one. From a voice application like mission critical push to talk, does the Sequans CA-410 module support MCQC-Eyes and EMBMS for multicast?
And no, it doesn't. That's the simple answer.
Okay. And that did not have a follow-up to it. So that's the last question from the audience. Mark, I'll turn it back to you for any final comments from the panelists.
No additional final comments from me. I'll go around and see if anyone else has any final comments. Start with Mitesh.
Well, first of all, thank you for the questions and the opportunity to speak again. I think we talked about technology and collaboration, and I think one of the things I would say is this collaboration of these partners that we have on call and other industry partners, it really plays a crucial role in accelerating the ecosystem, right? Especially for 900 MHz and CBRS, it drives the innovation, bring out a solution to the market, brings the awareness to our customers, helps them from supply chain perspective, regulatory perspective. So I think all in all, efforts like this, collaborative effort like this across the industry partner is a very positive thing for customers, and it helps us deliver the value to our customers that they are looking for really from us. So look forward to continue collaboration with you all, and partnering with our customers in bringing the solutions that they really desire, enable their use cases and applications that, and again, going back to our GE Vernova mission, continue to digitize and modernize the grid and to electrify the world. So looking forward to continue. Thank you.
Thanks, Mitesh. Al, any final comments?
Yeah, I just I'm really excited about working in both the utility space and in the wireless space for 40 years of my career, and I think this is probably one of the most exciting times I've experienced. I think we're on the verge of some really exciting and interesting things and capabilities, and I just believe we're gonna have a lot of fun over the next few years deploying this technology and seeing how it fits in. One of the things that we know that this technology is going to do is it's going to improve the reliability of our national grid deployments, and it's going to really improve customer satisfaction in the electric utility space and other utility spaces as well. So I've been following the Anterix journey since the start, and what Anterix has done is actually pretty unique and amazing, dealing in this RF spectrum space. So I'd like to just say hats off to Anterix, and hats off to our colleagues here that have stepped up and is wading in waist deep right now to bring this technology to market.
All right, thanks, Al. Yaniv, any final comments?
I couldn't. Sorry for that. Oh, I missed that. Sorry.
Oh, just any final comments you'd like to make? All right, thank you. Thanks, Yaniv. John, any comments you'd like to make?
Yeah, I'd like to wrap up with a few thank yous, if that's okay. First off, thank you to Sequans for bringing to market a module which slots in really well into the supply chain area and addresses the demands that we've had from utilities for these two bands. They're not previously available in a single module. So a thank you to you. The second thank you is to Mark and Anterix, not just for this particular webinar, but also for bringing to market with a great deal of foresight, some spectrum that really is going to be pretty critical to utilities. One thing I'd like to say about spectrum is that it doesn't grow on trees and it's not made anymore. So utilities out there, if you want to build a private LTE network, you need to get organized and actually looking at spectrum. Otherwise, you'll find that your options have been closed off. Next, I'd like to thank Bobby and UBBA for putting this session together. It's great. It's always good to have the UBBA input. It's a great organisation, and I'd highly recommend, if you're not already signed up as a member, that you do so. That's pretty much from me. I think that everyone has done a really good job on this webinar. There's a variety of different aspects and angles of the marketplace, and you can see, I think, from the vendors that are here today, that it's a very active and lively marketplace, and there's a lot happening. So you want to be part of it. You need to join outfits like UBBA. You need to talk to Anterix, get some spectrum, and then there's a whole bunch of big vendors that will be to pass to your door with their various solutions. So thank you.
Thanks, John. I too would like to thank today's panelists. It was a great job by everyone. Very interesting conversation, and thank you, Bobby.
My pleasure. And I would also say thank you. And I would just like to encourage our listeners to visit with each and every one of these companies at Distributech. I know we'll all be there, as will UBBA with a large booth. So feel free to stop by and ask questions, but do stop in and see these guys. Continue the conversation. Don't let this be the end, because it does take all of us to move the industry forward. And I'm very grateful to be part of this. So for now, from UBBA, I want to thank you all. I hope you have a great rest of your day. Stay safe and take care of each other. Thanks, everyone.
Thank you.
Thanks. Bye.
Yeah, cheers.